Good day, math buddies! Sir Sherwin here, your math instructor. For today's video, we will be discussing all about distance and midpoint formula. Of course, we will be guided with this objective, and that is to solve distance between 2 points and find its midpoint. Take note of this one. The distance between 2 points is always non-negative. It is positive when 2 points are different, and 0 if the points are the same. This time, let us talk about distance between 2 points. If S and R are 2 points, then the distance from S to R is the same as the distance from R to S. That is, segment SR is equal to segment RS. Let us also consider 2 points that are aligned horizontally on the coordinate plane. The horizontal distance between these points is the absolute value of the difference of their coordinates. Here, the value of our y is equal, wherein y sub 1 is equal to y sub 2. Mathematically, solving for the distance between 2 points when y coordinates are equal, our equation would be distance is equal to the absolute value of x sub 2 minus x sub 1, or we can say distance is equal to the absolute value of x sub 1 minus x sub 2. Let's have some of the examples. First, if point A has a coordinate of 2, 3, and point B has a coordinate of negative 7, 3, here, y sub 1 coordinate and y sub 2 coordinate is equal. They are both equal to 3. In this case, our formula is D is equal to the absolute value of x sub 2 minus x sub 1. By substitution, D is equal to the absolute value of negative 7 minus 2. D is equal to negative 9. This is a result when we combine negative 7 minus 2. And the absolute value of negative 9 is positive 9. Therefore, the distance between point B to A is 9 units. On the other hand, if we will be utilizing this formula, V is equal to the absolute value of x sub 1 minus x sub 2. Here, x sub 1 is equal to positive 2, while x sub 2 is equal to negative 7. To simplify this equation, distance is equal to the absolute value of 2 plus 7. The sum of 2 and 7 is 9, and the absolute value of 9 is equal to positive 9. Therefore, the distance of point A to point B is 9 units. Another example. Here, point A has coordinates 13, negative 1. And B has coordinates 7, negative 1. We will utilize the equation D is equal to the absolute value of x sub 2 minus x sub 1, where x sub 2 is 7 and x sub 1 is 13. 7 minus 13, the result is negative 6, and the absolute value of negative 6 is positive 6. Therefore, we can say that the distance of point B to A is 6 units. On the other hand, if we will utilize the second formula, D is equal to the absolute value of x sub 1 minus x sub 2. Here, x sub 1 is 13 and x sub 2 is 7. So the difference between 13 and 7 is 6. Therefore, the absolute value of positive 6 is also 6. So therefore, the distance of point A to point B is 6 units. This time, let us try to consider 2 points that are aligned vertically on the coordinate plane. Here, the vertical distance between these points is the absolute value of the difference of their y coordinates. And looking at the graph, we can consider that the value of our x sub 1 is equal to x sub 2. Therefore, finding for the distance between 2 points in a vertical line, we will consider this formula. D is equal to the absolute value of y sub 2 minus y sub 1, or distance is equal to the absolute value of y sub 1 minus y sub 2. Let's have some of the example. Here, point A has coordinates 5, 4, and point B has coordinates 5, negative 3. Our x sub 1 is equal to x sub 2. Therefore, the formula to be used is distance is equal to the absolute value of y sub 2 minus y sub 1. By substitution, y sub 2 is equal to negative 3 and y sub 1 is 4. To simplify, V is equal to the absolute value of negative 7. And the absolute value of negative 7 is positive 7. Therefore, we can consider that the distance of point B to A is 7 units. On the other hand, if we will utilize the second formula, distance is equal to the absolute value of y sub 1 minus y sub 2. Distance is equal to y sub 1 is 4 and y sub 2 is negative 3. To simplify, that is equivalent to distance is equal to the absolute value of 4 plus 3. The sum of 4 and 3 is 7. Therefore, the distance is 7 units. Then we can consider that the distance of point A to point B is 7 units. Another example. Point A has coordinates negative 8, 8, and point B has coordinates negative 8, negative 8. Again, the value of x sub 1 and x sub 2 is equal. Then we will utilize this formula. Distance is equal to the absolute value of y sub 2 minus y sub 1 by substitution. Y sub 2 is negative 8, y sub 1 is positive 8. By simplifying, distance is equal to the absolute value of negative 16 and the absolute value of it is positive 16. Therefore, the distance of point B to A is 16 units. On the other hand, if we will utilize the second formula, distance is equal to the absolute value of y sub 1 minus y sub 2. It follows that our y sub 1 is positive 8 and y sub 2 is negative 8. By simplifying, this is equivalent to distance equal to the absolute value of 8 plus 8. The sum of 8 and 8 is 16. Therefore, the distance of point A to B is 16 units. This time, let us discuss distance formula. Distance formula is used to determine the distance between 2 points, whether or not they are aligned horizontally or vertically. So let's consider the points A and B whose coordinates are x sub 1, y sub 1, and x sub 2, y sub 2 respectively. This is illustrated in our graph. Here, if A and B are two distinct points, then let us form a broken line from A perpendicular to the vertical and a broken line perpendicular to the horizontal. The intersection is point C with coordinates x sub 2, y sub 1. So here, right triangle is formed and we can utilize the Pythagorean theorem in solving for the distance of segment AB. In the Pythagorean theorem, it states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. In this case, the distance between point A and point B is the same as the absolute value of segment AB squared is equal to the absolute value of segment AC squared plus the absolute value of BC squared. The length of segment AB is equal to square root of the quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. Or, we can also write length of segment AB is equal to square root of quantity x sub 1 minus x sub 2 squared plus quantity y sub 1 minus y sub 2 squared. This is our distance formula, represented by distance is equal to square root of quantity x sub 1 minus x sub 2 squared plus quantity y sub 1 minus y sub 2 squared. Or we can write in the form distance is equal to square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. Let's try to have an example. Let's find the distance between the points M with coordinates 2, 3 and L with coordinates negative 4, 4. Utilize our distance formula. With this, substitute x sub 2 which is negative 4, x sub 1 which is 2, y sub 2 which is positive 4, and y sub 1 which is equal to 3. Then simplify. Negative 4 minus 2 that is negative 6, and 4 minus 3 that is equal to 1. Quantity of negative 6 squared that is 36, while 1 squared that is equal to 1. The sum of 36 and 1 is 37. In this case, 37 is not a perfect square, and it doesn't have a factor where one is a perfect square, the other is a non-perfect square. So therefore, we can consider that the distance between M and point L is square root of 37 units. Let's have another example. Find the distance between the points D with coordinates 5, 3 and point G with coordinates 2, 7. Again, utilizing our distance formula, substitute our x sub 2 which is equal to 2, x sub 1 which is equal to 5, y sub 2 which is equal to 7, and y sub 1 which is equal to 3. To simplify, 2 minus 5 that is negative 3, and 7 minus 3 that is equal to 4. Negative 3 squared that is equal to 9, 4 squared that is equal to 16. Adding 9 and 16, that is equal to 25. Square root of 25 is 5. Therefore, the distance between point D to point G is 5 units. Another example. Let us find the distance between 2 points P with coordinates negative 6, negative 1, and S with coordinates negative 2, negative 9. Substitute our x sub 2, which is equal to negative 2, x sub 1, which is negative 6, y sub 2, which is negative 9, and y sub 1, which is equal to negative 1. To simplify our equation, we will come up with segment PS is equal to square root of quantity negative 2 plus 6 squared plus the quantity negative 9 plus 1 squared. 4 is a result when we combine negative 2 and 6, while negative 8 is a result when we combine negative 9 and 1. Simplify our equation, segment of PS is equal to square root of 16 plus 64. Combining 16 and 64, the result is 80. 80 is not a perfect square, but it has factors 16 and 5. So therefore, the distance between point P to point S is 4 square root of 5 units. Let us also discuss midpoint of a segment. It is the point on the segment that is midway between the endpoints. The average of the x coordinates and y coordinates are the coordinates of the midpoint. So mathematically, it is illustrated as m is equal to the quantity x sub 1 plus x sub 2 all over 2. This is for our x coordinate. And y sub 1 plus y sub 2 over 2. This is for our y coordinate. Let's have an example. The coordinates of the endpoints of segment AB are negative 7, 3, and 11, 9. What are the coordinates of its midpoint? Again, utilizing our midpoint formula, substitute our x sub 1, which is negative 7, x sub 2, which is 11, y sub 1, which is 3, and y sub 2, which is equal to 9. To simplify, first, our x coordinate, negative 7 plus 11 all over 2, that is 4 over 2, while simplifying 3 plus 9 over 2, that is 12 over 2. So 4 halves is equal to 2, and 12 halves is equal to 6. Therefore, we can consider that the midpoints of segment AB are 2 and 6. Another example. The coordinates of the endpoints of segment US are 2.5 and 7.1, and 8.5, 9.5. What are the coordinates of its midpoint? Again, utilizing our midpoint formula, substitute our x sub 1, which is 2.5, x sub 2, which is 8.5, y sub 1, which is 7.1, y sub 2, which is 9.5, then simplify. 2.5 plus 8.5 divided by 2, that is 11 halves, while 7.1 plus 9.5 all over 2, that is 16.6 over 2. Therefore, the coordinates of our midpoint of segment US are 5.5 and 8.3. Another example. The coordinates of the endpoints of segment RP are 4, 12, and 11, 5. What are the coordinates of its midpoint? Again, utilizing our midpoint formula, substitute our x sub 1, which is 4, x sub 2, which is 11, y sub 1, which is 12, and y sub 2, which is equal to 5. Simplifying 4 plus 11 over 2, that is 15 halves, and simplifying 12 plus 5 over 2, that is 17 halves. So in decimal, midpoints has coordinates 7.5 and 8.5. This time it is your turn. Find the distance between each pair of points using the distance formula. Number 1, A has coordinates 2, 6, and B 2, 11. Second, point C has coordinates negative 8, 10, and point D has coordinates negative 3, 10. And the third one, point E has coordinates 5, 9, and F with coordinates 7, 8. Likewise, let us also find the coordinates of the midpoint if the given endpoints are also given. There you have it. Hope you learned something new today. God bless us all.